Etsy is located in New York, in Brooklyn, where all the cool hipsters are. And it's well known for its company culture, things like embracing failure and postmortems, and monitor everything. If you heard about StatsD, stuff like that, they were one of the first, to write about that and present in DevOps days. And Bethany is here as she's a core platform developer at Etsy, and she's going to tell us a few of the secrets of the data migration team, which is a very difficult, complex subject. I'm excited to have you here today. Please help me welcome Bethany.
Good morning. I'm Bethany Macri. It's my first time in Israel. I could not be happier to be here. I actually didn't think I was going to make it here. I flew on El Al, and in New York, they asked what I did, and I said, I'm a software engineer, and they said, oh, did you study that in school? And I said, no, I'm self-taught, and they took my bags and escorted me to the gate. So, like a criminal, but I'm not a criminal. I'm a software engineer at Etsy on the core platform team. We are an infrastructure team, so we kind of live we're a hybrid of development and operations. So who has not heard of Etsy? Okay, perfect. So for those of you who have not heard of us, we're a Brooklyn-based company. We enable people to sell their handmade and vintage goods online and make a living for themselves. We were founded in 2005. We now have over 700 employees. We just went public in the spring, so we're now a public company. We have 32 million items for sale online currently. We have 1.5 million active users. And we now have transactions in nearly every country in the world, including Israel. Technically speaking, for the most part, we run a LAMP stack. Does everyone know what that is? Okay. And we have a monolithic code base. So not overly exciting in that respect. What is exciting about Etsy, and I think what sets us apart technically, is that we practice continuous deployment. And we're pretty good at it. We push 35 times daily. The thought behind continuous deployment is that a small change is easier to understand, it's easier to test, and it's easier to fix. In fact, it's so easy to detect a change when it's so small that when something breaks, we're often able to roll forward with a fix rather than revert or back it out. This is to say that our failures are kept small, or if our small change does cause a catastrophic failure, it's very easy to pinpoint. You know exactly what caused the error. We do not have release managers, build managers, or a QA team. We do that all ourselves as engineers. There are no barriers to pushing. This is actually our former CTO's t-shirt company that he used to sell these t-shirts on Etsy, and this is one of our aesthetics, to borrow a term from the keynote speaker. Continuous deployment fosters and maybe even forces DevOps collaboration. This is the ratio of software engineers to operations engineers at Etsy. There is both a clear separation and shared responsibility between engineers and ops engineers. For us, DevOps is not only about having dev and ops be the same thing. We have really good engineers, we have really good operations engineers, but we cooperate. Whereas typically you have engineering in one silo and operations in another silo, and they don't talk. Or when they do talk, it's contentious because development makes some feature or piece of infrastructure and lobs it over the gate to operations, and operations says, no, you're insane. And then development sees operations as blocking their deadline. We have developers who are empowered to think about the operational implications of their code. And we talk early, we talk often, we talk before deploy, we talk after deploy, and we perform game days with our operations engineers. What underlies this cooperation, and what I believe is the most important thing that sets Etsy apart, is our culture of blamelessness. That means we conduct blameless postmortems when something goes wrong. There's no pointing fingers, and yet this does not mean no responsibility is taken. Having what we call a just culture means that you're making effort to balance safety and accountability. and that people who made the mistake are empowered and enabled to give a detailed account without fear or punishment of retribution. Now, this does not mean that Etsy has a cushy, kumbaya environment. Rather, we don't tolerate pointing fingers. We don't tolerate assholes. And we recognize that failure happens. It's not a surprise. There will be bugs. This is a foregone conclusion in working with complex systems. We believe that failure is inevitable. At the same time, expensive failure is not inevitable. We often ask ourselves how we can fail quickly, how we can fail in a small way, how we can fail in a way, since we're an e-commerce site, that doesn't prevent people from checking out or doesn't, for example, prevent people from making new accounts on our website. One way in which we keep our failures small is by using tools. And that's what I'll be discussing today. How myself and a team of 4 other engineers use tools to complete a very daunting data migration project. Who has completed a data migration project? Okay, so you know, it sucks. It blows. And the reason it blows is because it's scary. It's scary to lose data, it's scary to corrupt data. So you have to move safely, and when you're working under a deadline, as we were, you have to move quickly as well. So why did we want to complete this migration? When we began in 2005, we started storing all of our data on a Postgres primary-secondary database. Around 2011, when our growth really started skyrocketing, we realized that Postgres could no longer work for us. First, it was a complete single point of failure in our system. Secondly, we had stored procedures in the Postgres schema, and they were very difficult to iterate on. And as I mentioned before, we're used to pushing code 35 times daily. So it was, in terms of our engineering culture, it was a counterexample of that. The stored procedures were also very difficult, if not impossible, to test. Lastly, and perhaps most importantly, Postgres would also cause problems as we tried to scale. In fact, we got to the point where we could no longer vertically scale the box. Our solution to this was to implement what we call MySQL shards. The following is a simplified diagram of how the shards work. So we have a PHP application. A unique primary key is created on what we call a ticket server. This provides a globally unique primary key. We then go to a database called index. By default, index randomly assigns which shard the record will be stored on. And finally, we write to the shards. You'll notice that each shard has a side A and side B. This is a primary setup and prevents a single point of failure. This also allows us to do schema changes while maintaining without downtime. So we take, for example, side A out, apply the schema change to it while side B is in, put side A is out, put side A back in, and do the same for side B. So I mentioned that this data migration was particularly daunting. That is because it affected the entire Etsy universe in terms of the code base. We began this in 2011, and what remained at the beginning of 2015 were 2 tables, receipts and transactions. Here's a short list of what receipts and transactions data affects at Etsy. Financial reports. This is especially a touchy subject for us now. As I mentioned, we just went public, so we do not want any of our financial reports reporting false information. Checkout. So the ability to create a receipt upon checkout can actually halt the checkout. So if you cannot create a receipt or a transaction, you're not able to check out. Marking a receipt as paid or shipped. This is something important to both the buyers and the sellers, but more so to the buyer, as they've often already put money down on the item. And people get very sensitive when they've already purchased something. Email notifications as to when the item will be shipped and arrive. A seller paying their bill, and our search infrastructure and big data jobs that make recommendations based on prior purchases. So as you can see, the scope of this project, in addition to just being a data migration where you don't want to lose data, the scope of this project was enormous. So we made a plan. First, we would move rights. We called this teeing rights. So at each place in the code base where we were writing to Postgres, we would also write to the MySQL shards. Secondly, we would backfill data from Postgres to the MySQL shards, data that preceded or happened before, or was created before, rather, the teeing of the writes. And finally, we would move reads from looking to Postgres to looking at the shards. Moving reads might sound simple. It was not. It was extremely complex. And the reason is, I'll first go back to this slide. So you'll recall our sharded architecture. Moving writes here was complex because of this architecture. This architecture requires a compound primary key because it stores the shard that the record is stored on and also the record itself. In many cases, some pretty gnarly and nuanced refactoring had to be done to accomplish this. And the fear was that while we were trying to tee to Postgres and to the shards, that we would actually lose the write to Postgres and lose data or corrupt data. And the shard, what we call the shardifier, so the shard number that the record was stored on was not always in scope or even in the class or the inheritance tree of the write location. So that's what I mean by very nuanced, gnarly refactoring. So to get back to this slide, the most important thing we had to ensure here is that we wouldn't clobber writes to master. For this, we used our feature framework. This is an example of an if statement using our config flags in our feature framework. They act as a knob for requests. So we can enable a feature as the one I have here and ramp it up, assigning it a non-zero number value in the config. When the feature is enabled to 100%, all requests will go through the control flow underneath this line. So, for example, if we were uncertain or feeling unconfident, which was often because of the complexity of this project, we would use config flags and we would ramp it up first to 1% and see if receipts were being still created and updated properly on Postgres. Once we were sure that we were writing both to Postgres and MySQL and all locations across the code base, we were then ready to backfill and verify data. We had to verify that each record in Postgres was also on MySQL and that all columns corresponded correctly. We call this step backfill and verification. For this, we used Gearman, which is an asynchronous job queue. I'll get back to this slide, but first, this step, backfill and verification, necessitated a lot of bulk querying for efficiency. The danger here is that we would take down index, and if you hadn't noticed before, this is our new single point of failure in our system, and I hope that next year I'm able to give a talk about how we fixed that. But currently, this is a single point of failure in our system. So if you take down index, the site's down. So for backfill and verification, we didn't want to pummel index and risk taking the site down because we wanted to do this data migration entirely online with no downtime. So we use this asynchronous job queue as to not hit index every time we needed to look up a record on the shards. So you can see here that this is the Gearman architecture. Jobs are queued in a job server where they wait. This is the asynchronous part. And then once a job is released, a worker process completes the job. Pummeling index with queries would likely take down the site. So instead, we wrote a Gearman job that would query only so many records at a time. And in that way, we were able to rate limit the hitting or the querying of index. Finally, we moved reads. This was a giant task and perhaps the most intimidating part of the project because accessing this data happened all over the code base. We also had to make sure that the methods in each of the Finder classes were in parity. This took a lot of careful auditing time, implementing time, and testing time. We had to ensure that each query was returning the same data from both Postgres and the shards. We started moving reads in July, this past July, and the project was, the deadline for the project was the end of this September. So the risk here was that because the scope and the number of read sites was so great that we wouldn't complete the project on time. This is significant because we are an e-commerce site, as I mentioned, and we do not want significant changes happening to the site during US holiday shopping time, which essentially starts in October and goes through the end of the year. So by not finishing in September, this would have pushed the project into 2016, which was a big no-no for us. So we use Spatch, and this is the patch file, and we applied it globally. So this is not a perfect solution, and the reason is very specific to Etsy's architecture. But we have in the sharded world, in the MySQL world, records stored by shop and by user. And we call these variants. So what would have been ideal is to have a mechanism that could detect whether a Postgres receipt actually corresponded to a user receipt or a shop receipt on the shards. This is completely a human task. It cannot be machine automated. So this is a pretty good solution. It's not a perfect one, but it ended up saving us and allowing us to finish the project on time. The reason is that in this T-Finder, we built a tool to compare the results that were being returned from Postgres and from MySQL. And so we were able to pinpoint where in the code base those results were not the same and to fix them individually. I'll reiterate that doing this manually would have caused us to not finish the project on time. Doing these by hand so late in the project, I think would have also caused a significant amount of engineering burnout. Again, this was a 9-month data migration project, and the longer, as you know, a long-term project goes on, the more at risk you are for engineering fatigue and burnout. By using tools to automate and protect ourselves, we largely avoided this kind of engineering burnout. Again, at Etsy, we acknowledge that failure is possible and even inevitable. Here are 5 Etsy employees last Halloween dressed up as a sort of famous bug that we wrote that caused 5 stars in the Etsy app to show up as 4 stars and a horse. When you acknowledge that failure is inevitable, but that expensive failure is not, you can actually celebrate your mistakes rather than being ashamed of them. You can learn from them. You can build a safer system. You can protect yourself from expensive failure. You can use tools for salvation. Thank you. Questions? Hi.
Two questions. One is, why did you choose an independent solution, homegrown solution, versus using like a off-the-shelf scale database? And then what happens when you need to have more massive data?
So the question was, why did we not use an out-of-the-box solution as opposed to the shards? And then the second question was, I'm sorry, I'm really jet lagged, remind me? How do we scale out? So the first, the answer is that we inherited a large number of engineers from Flickr. And Flickr had a pretty funny and famous problem where during the 2008 election, is everyone familiar with Flickr? Okay, okay. During the 2008 US presidential election, President Obama created a Flickr account and took the site down because it was so popular. So the engineers from Flickr learned from that and brought their experience over to Etsy. And what the shards allows is a reapportionment of the data. And so that goes to speaks to your next question, which is how do we scale? We scale horizontally. And the shards now, my slide is a lie. Let me go back to it. So, okay. So, yeah, this is a total lie. I'm sorry. The reason it's a lie is that it makes it seem that the shards are one box, one database per box. We actually have logical shards, so we have multiple databases per box, and so we can scale by moving data around as we add boxes. Does that answer your question? Other questions? Yes.
Did you think of using a consistent hashing algorithm instead of needing a specific hash and then all this refactoring, like something more implicit?
As opposed to randomly assigning the shards?
Yeah. So you won't have to refactor all the code in every place to have a primary key that is both the original key and the shard. So just you get the key and then you say, okay, this is shard 2, just because the hash of the key is whatever.
Right. That would have been the question was, why didn't we consider a consistent hashing algorithm rather than a compound primary key? I think that would have been a better way to go in hindsight. Yeah. Yes?
Do you do cross-shard joins?
No. The question was, do we do cross-shard joins? No, we do not. We try to keep our SQL as simple as possible. It does happen in the code base. It's very rare. We try to keep it as PK lookups globally. Yes?
Where do you store files? In the shards, or do you have a separate location? I uploaded images.
So the question was, where do we store files, on the shards or some other place? The answer is, we have an entire photos stack. Those are actually stored in our own database, but not on the shards, and eventually in S3 once they get older. Is that what you were asking? Yeah. Yes?
Could you give a hint on how you manage the index, how you manage to make it non-false points? Which is that you're going to...
So the question is, how did we make index not a single point of failure? We haven't yet. No, we hope to. That's some of the work that we'll be doing in 2016.
What are your ideas?
I don't know. I think distributing index would be extremely complicated, so that's why we haven't done it yet. We don't have any, there's no clear road forward. Do you have any ideas? Oh, all right. Any more questions? Okay, thank you so much.